Good morning. Welcome to my presentation. I am M.A. Motalib Hossain from Nanotechnology and Catalysis Research Center, University of Malaya. I am going to present about molecular-based techniques for the authentication of meat products. Meat is very important as a food. Approximately 2 billion people worldwide depends on meat to fulfill their nutritional requirements. Meat contains high quality proteins, essential amino acids, and it rich in vitamin and minerals. Nowadays, adulteration of food is an emerging and sensitive issue, where I want to present some example of adulteration scandal. Pork DNA was found in 85% tested beef products in Europe, 38% in South Africa, and 26% in Arabian Gulf countries. Horse DNA was also found in 37% tested beef products in Europe. Buffalo DNA was also found in beef products. China police seized approximately 20 ton fake beef, which was made chemically treated pork. Animal species carry zoonotic threat. According to USDA, approximately 75% infectious disease of human comes from animal origin. Animal species causes allergic reaction to sensitive person. Therefore, detection of animal species in food products is very important. Food authentication techniques, detection of animal species. Among the existing techniques, one is the morphological detection method, which is unsuitable for the processed food products due to lack of specific morphological features. It may be used only for raw meats, but not for hot, because it cannot differentiate the very which is very morphological very close. This type of meats cannot identify or differentiate using the morphological detection technique. Another one is the protein-based technique. It can be used only for raw meat because protein is denatured easily and protein is heat unstable, and protein-based techniques is unable to differentiate the closely related species. Another one is the molecular-based techniques or DNA-based techniques. This techniques is highly specific, more sensitive, and DNA is high thermostable, and this technique is able to differentiate very closely related species, for example beef and buffalo. So the molecular based technique is the most suitable techniques for the detection of animal species in processed food products. The common and useful molecular based technique is the polymerase chain reaction or PCR method, which is two types. One is conventional PCR, another is a real-time PCR. Conventional PCR is used only for qualitative detection, while the real-time PCR is used for both qualitative and quantitative detection. Food authentication by PCR techniques, where I want to show the brief explanation of the PCR method. Initially, DNA was extracted from the meat products using the DNA extraction kit. Later on, PCR experiment is carried out using the extracted DNA and PCR components such as primer, buffer, magnesium chloride, DNTP, and TECPOL. In the PCR experiment, from one copy of DNA is amplified to a million copy of DNA. From one copy of DNA in the first cycle, amplified 2 copies of DNA. From 2 copies of DNA, amplified into 4 copies of DNA by second cycle. By third cycle, from 4 copies of DNA amplified to 8 copies of DNA. By this way, millions of copies of DNA is produced after PCR experiments. The amplified PCR products was visualized in gel electrophoresis. In the gel image, the different bands indicates the different species. Due to the size of the bands, we can identify the species. By this way, by using the PCR techniques, we can detect the species in food products. Now, double targeted PCR assay. There are 2 types of PCR assay regarding the target side. One is the single gene targeted and the double gene targeted. Single gene targeted means the single gene, in single gene targeted, single gene is targeted, and in case of double gene, 2 gene is targeted in its reaction in the PCR assay. For example, if we want to detect the pork species in food products, for developing the double gene targeted gene, 2 different genes, for example, one gene from cytochrome B and another one is ND5 target. Double gene targeted PCR. Why double gene targeted PCR? Because it offers more advantages where double layer security is present. If one target is missing due to heat treatment or other food processing treatment, second target will complement the missing target. So there is less possibility of false negative result. For the first time, we developed double gene targeted multiplex PCR assay for the detection of beef, buffalo, and pork. Initially, we optimized simplex PCR assay, then gradually optimize duplex, triplex, tetraplex, and finally hexaplex or multiplex PCR assay, where 6 band is showing in a single length It indicates the multiplex PCR assay for 6 different PCR products, where 2 products for beef, 2 products for buffalo, and 2 products for pork, because we have targeted 2 different genes for each species. Where electropherogram also showing 6 different peaks corresponding to 6 different bands of gel lengths. Limit of detection was determined using the serially diluted DNA from the 10 nanogram to 0.02 nanogram DNA. Our developed double gene targeted multiplex PCR assay successfully amplified up to 0.02 nanogram DNA, whereas the 6 band is clearly showing from 6 targets, and electropherogram also showing the 6 different peaks. So the developed method was highly sensitive. The method was also validated using the adulterated meat products. To validate the PCR assay, we prepared beef, buffalo, and pork meat in our laboratories, and each meatball product was deliberately adulterated with other species. For example, beef meatball was adulterated with buffalo and pork. Buffalo meatball was adulterated with beef and pork. Similarly, pork meatball was adulterated with beef and buffalo. The percentage of adulteration was 1%, 0.5%, and 0.1%. And 0.1% adulterated sample was autoclaved for 2 and 2.5 hours. Our developed method successfully amplified up to 0.1% adulterated sample. So the method is highly sensitive. If adulteration was in the sample 0.1%, the method can detect and up to 0.1% adulteration. We also developed another heptaplex PCR assay, which successfully detect 7 highly consumed meat species such as pig, cat, dog, cow, buffalo, chicken, and fish, where 7 different bands in a single line, which indicates the multiplex PCR of 7 different targets, and the electropherogram also showing the 7 peaks corresponding to 7 bands. The LOD of the heptaplex PCR assay was 0.1% for buffalo and 0.001% for other 6. To quantify the adulteration, we also developed real-time PCR assay to generate the standard curve as well as to determine the limit of detection. 10 times serially diluted DNA from 30 nanogram to 0.003 nanogram DNA were used. Our developed real-time PCR assay successfully amplified up to 0.003 nanogram DNA, indicating the limit of detection of the developed assay was 0.003 nanogram. And from the implementation curve, CT value of the implementation curve was used to generate the standard curve. Here is the beef standard curve for beef, and this one standard curve for buffalo, and the efficiency of the real-time PCR assay was found within acceptable limits. Here the standard curve for pork, and this one standard curve for internal amplification control. To validate our method, we brought pork, beef and chicken food products such as meatball, frankfurter and burger from the local market of Malaysia, and these products were analyzed using our developed PCR method. The result was found 58% tested beef products were adulterated with buffalo. However, adulteration was not found in chicken and pork products. So, adulteration is a common phenomenon especially in beef products. Conclusion: first report of multiplex PCR assay for the differentiation of beef, buffalo and pork. First report of double gene targeted PCR assay which would provide greater certainty compared with a single target system. Detection limit was 0.02 nanogram DNA in pure state and 0.1% meat in mixed matrices. Quantification limit was 0.003 nanogram DNA in pure state and 0.1% meat in mixed matrices. Thank you for your kind attention.